engineering. So in this video we are going to start doing the Fourier series. Now, the Fourier series is about periodic functions. Now, what is a periodic function? Well, a periodic function is a function that actually repeats itself, right? Now, for example, this is a seesaw function. So here it goes up and then goes down, up and down, up and down, and repeats itself. Now, repeat itself is very important because if you shift the function exactly the period of repetition, it overlaps itself. So that is the definition of a periodic function. Something that repeats itself a certain amount of time. Now, this is the seesaw. Now, it could be like this, or it could be just like a square function. Okay, now, the important thing here is that mathematically, the period here is equal to 1. T is equal to 1 now. If you shift the function exactly the period, is going to be equal to the same function itself. Now the period could be 1, or could be 2, or could be whatever. Now in the example below, it's actually pi. So g of x plus pi, I am moving the function exactly pi, and it's going to be equal to the g of x. Okay, now what happens here is that what Fourier found was that, I'm going to write this, Fourier discovered that any periodic function could be approximated with a proper combination of sines and cosines. Okay, now, if you remember, the sine is also periodic function and the cosine is also periodic function. That is why we have seen these formulas. Okay, now, it's saying that if you find the correct sine and the cosines, okay, that f of x could be with a proper combination of the sine and the cosines. What combinations we don't know. It could be like 5 sine of x minus 3 sine of 2x. Also the cosines plus I don't know, 1/3 of the cosine of 5x, and so on. With a proper combination of this sine and the cosines could be make it equal to this periodic function. Something like this. Something like this. The cosines like that. Alright. Now another proper combination. This is the combination to match this seesaw function. Now another combination, different combination, we can make g of x. G of x will be like minus 3 sine of 2x, like plus I don't know, 5 cosine of x, sorry, plus 7 sine of 100x plus whatever. Alright. Now, with the proper combination of the sine and the cosines, we can model like this. We can approximate this combination of the sine and cosines to the periodic function, something like this. It won't be exactly the same, but it's going to try to follow the periodic function. Alright? So that is the magic of the Fourier series. Now, series because it is not only one single sine and a cosine, it's a series of the sine and cosines. Right? So he discovered that with the proper coefficients, you can match the sine and the cosines to the periodic function. Okay, now, what is the right combination? That is the task of this unit. What is the So here, what is what are the coefficients? So that is actually the task of this unit, to find out what are these proper coefficients to make this equal. So our task is going to be these coefficients. Now, the Fourier series is something like this. He said that a periodic function f of x could be written like a0 plus the addition of from n equal to 1 to infinite. Here, an cosine of nx plus bn sine of nx. Now here you have the summation, the addition, because you are going to add together sine and the cosines. Alright? Now the task is again what are these coefficients an, bn, and so on, which means these coefficients. What are the values of those coefficients? So those coefficients are this, this, and this. Now, how are we going to find those coefficients? Okay, we are going to discover how to calculate those coefficients on the next video. But this unit, it is actually trying to find these coefficients, so that if you happen to have a periodic function, you are going to match this Fourier series to the periodic function, and the task will be to find what are those coefficients. Now, be careful here, infinite, okay? This is very important, because if you add more cosines and sines, then more accurate will make the match of the Fourier series with the periodic function. Okay, now if you choose like n, if you make from n equal to 1 to just 3, so it's not going to be very accurate. So the more, the better. Alright, so in Fourier series, he decided, okay, let's make it to infinite. Alright, now infinite is a very long task, but we are going to try to find those coefficients. Okay, see you in the next video to see how to calculate those.